Welcome to the DIY Honda Garage channel. The DTC P16F4 denotes a low-voltage condition in the starter cut relay 2 control circuit of the Honda Civic models from 2011 to 2015. This issue can prevent the engine from starting, as it compromises the communication pathway between the powertrain control module, PCM, and the starter cut relay. The starter cut relay itself is integral to the starting system, controlling the flow of current to the starter motor. Its location is typically within the underhood fuse/relay box, while the PCM is found in the engine compartment as well. To restore proper functionality, it's essential to determine whether the problem lies within the wiring, the relay, or the PCM itself. Effective troubleshooting involves systematic checks to ensure that all related components and circuits are performing as expected, following the diagnostic steps outlined in the repair guide. The error related to DTC P16F4 indicates a problem with the starter cut relay 2, which is a critical component that directly influences the engine starting process. This relay is responsible for controlling the electrical current sent to the starter motor, ensuring that the engine fires up when prompted. The powertrain control module, or PCM, communicates with the starter cut relay, sending signals that determine the relay's operation. The PCM is also responsible for managing various engine functions and ensuring optimal performance. The underhood fuse relay box houses the starter cut relay, situated in the engine compartment for easy access. An understanding of these components and their respective locations is essential for the troubleshooting process, as they directly influence the vehicle's starting capability. Several potential causes could lead to the activation of DTC P16F4. A shorted wire in the starter cut relay control circuit could prevent the necessary voltage from reaching the relay, thus inhibiting its function. Another possibility is a malfunction within the starter cut relay 2 itself, which might have failed to carry out the electrical commands sent by the PCM. Additionally, the PCM may be at fault. If its software is outdated or it is damaged, it could fail to communicate effectively with the relay. These causes must be thoroughly investigated to accurately identify the root of the problem and ensure a comprehensive repair is carried out, restoring full functionality to the engine starting system. The primary symptom associated with DTC P16F4 is that the engine may not start when the ignition is engaged. This prevents the vehicle from being operational and can be quite frustrating for the owner. Drivers may also notice the DTC warning light illuminating on the dashboard, providing a visual indication of an underlying issue with the starting system. Furthermore, in some cases, the vehicle could exhibit intermittent starting issues. Sometimes it may start without apparent problems, while at other times it may fail to engage. These symptoms not only indicate a failure in the starter cut relay mechanism, but also suggest deeper issues within the electrical connections and control circuits linked to the PCM and relay. The first step in troubleshooting DTC P16F4 is to attempt to start the engine. This initial check serves as a baseline for further diagnostics. If the engine starts successfully, it suggests that there may not be a persistent issue. However, it does not rule out intermittent faults. If the engine fails to start, this could indicate a more significant electrical problem, prompting a detailed examination of the starting system. The key here is to verify whether the starter cut relay and associated wiring systems are functioning correctly, or if an alternative issue exists. Understanding this first step is crucial, as it determines the direction taken in subsequent troubleshooting efforts. Once the engine attempt has been performed, the next step entails pressing the engine start-stop button to shift the system into off mode. This process effectively resets the system for a proper diagnostic cycle. Following that, the engine start-stop button should be pressed again to select the on mode. Using the Honda Diagnostic System, or HDS, the Diagnostic Trouble Code, DTC, should be cleared to refresh the vehicle's data records. Following the clearing of the DTC, it's essential to check again for any pending or confirmed DTCs present in the system. If DTC P16F4 is still indicated, this confirms that the failure is indeed persistent and needs further investigation. If not, it might suggest an intermittent fault that warrants checking for any poor connections or loose terminals in the starter cut relay and PCM systems. In this step, begin by pressing the engine start-stop button to select the off mode before proceeding. The SCS line should then be jumped utilizing the HDS, allowing diagnostic personnel to bypass normal signals for troubleshooting. Next, it's crucial to disconnect the PCM connector A51P and remove starter cut relay 2 from its placement in the underhood fuse relay box for accurate measurement. With both components disconnected, measure the resistance between the test points defined in the diagnostic. Specifically, this involves checking from the PCM connector A51P, number 11, ORIN, to the body ground. A reading of 1.0 megaohms or more would indicate that the ST-cut RLY2CL wire is intact and functioning correctly. Should the readings indicate lower resistance, this confirms potential wiring issues that need immediate attention. After verifying wiring integrity, the next step requires pressing the engine start-stop button to select the on mode, preparing the system for further diagnostics. The transmission shift lever should be positioned in either park, P, or neutral, which is essential for proper starting conditions. Utilizing the HDS, check the starter cut control return in the data list. This is a specific reading that indicates whether the starting circuit is properly engaged. If on is indicated, it confirms that the relay is receiving the necessary signals to operate correctly. However, if it does not show on, this will lead directly to the symptom troubleshooting guide for the engine being unable to start, indicating further issues within the starting circuit must be explored. For this troubleshooting step, again press the engine start-stop button to select the off mode and utilize the HDS to jump the SCS line. Disconnect the PCM connector A51P once more. You will now press the engine start-stop button to switch to the on mode. Following this, move the shift lever back into the P or N position for accurate testing. At this point, measure the voltage between the specified test points of the PCM connector A51P number 11 and body ground. A reading of battery voltage indicates that the IG1 ACG wire is operational. In such a case, either update the PCM software or replace the PCM with a known good alternative. If the DTC P16F4 clears after this process, troubleshooting is complete. This step begins by ensuring the engine start-stop button is in the off mode. Remove starter cut relay 2 from the underhood fuse relay box again. Subsequently, press the engine start-stop button to select the on mode, as this is crucial for the voltage measurement. You will next measure voltage from the starter cut relay 2 4P socket to body ground in the on mode. Confirm if there is battery voltage on the tested points. A clear signal indicates that the IG1 ACG wire is functional. If it registers lower voltage, it suggests an open in the ST-cut RLI2CL wire that should be repaired to restore proper communication and operation between the PCM and starter cut relay. To proceed with this troubleshooting step, press the engine start-stop button to set the system to off mode beforehand. Carefully check the condition of fuse number B2, rated at 10A, located within the under-dash fuse relay box. This fuse is integral to the functioning of the starter circuit, and a blown fuse can prevent the circuit from operating entirely. If the fuse is in good condition, further troubleshooting is warranted. However, if it is found to be blown, it should be replaced, and an inspection for any shorts to ground within the number B2 fuse circuit must be conducted. This could prevent recurrence of the issue and contribute to restoring the full functionality of the starting system. The final step in troubleshooting this DTC involves verifying the continuity of the IG1 ACG line. First, disconnect the under-dash fuse relay box connector D32P to isolate the circuit. Remove starter cut relay 1 from the underhood fuse relay box, and then connect terminals A and B with a jumper wire for continuity testing. Measuring between the specified test points will determine if the circuit shows continuity. If continuity is present, it confirms the integrity of the IG1 ACG wire. If the test indicates a lack of continuity, this signifies an open circuit requiring immediate repair. Ensuring all connections are solid and functional is key in reinstating the reliability of the Honda Civic starting system. Following the completion of all troubleshooting steps, it is imperative to perform a final repair verification. Start by ensuring that any diagnostic trouble codes, DTCs, have been cleared and are no longer present in the system after necessary repairs or component substitutions. Once confirmed, the next step involves testing the engine by attempting to start it under typical conditions. Successful ignition indicates that the issue associated with DTC P16F4 has been resolved effectively. Additionally, it's beneficial to monitor the starting behavior over some time to ensure stability and that the problem does not reappear. Monitoring helps in assuring the longevity and reliability of repairs conducted. Preventive maintenance is essential in mitigating the reoccurrence of issues related to DTC P16F4. Routine electrical inspections across the entire starting system can identify potential issues before they escalate. This includes checking wiring connections, relays, and the PCM for wear or vulnerabilities caused by environmental factors. Regular updates to the PCM software can also ensure it operates using the latest protocols, optimizing performance and addressing known issues. Implementing these preventive measures can help promote long-term reliability and functionality of the vehicle's starting system, significantly reducing the chances of future faults and enhancing overall vehicle performance. In summary, understanding the implications of DTC P16F4 is crucial for maintaining the health of the Honda Civic from 2011 to 2015. This DTC denotes a low voltage condition in the starter cut relay 2 control circuit, which is significant for ensuring proper engine starting. Systematic diagnostic steps must be followed to accurately identify the root cause of the issue, whether it be wiring faults, relay malfunctions, or PCM issues. Each step is designed to methodically isolate the problem so that effective repairs can be conducted. By performing thorough checks and preventive maintenance, vehicle owners can ensure ongoing reliability and performance of their starting systems, safeguarding against unexpected breakdowns and contributing to a positive ownership experience. Please like and subscribe to the channel. See you next time.